Have you ever seen something like this? You inject a value from your property file, everything looks correct, but when your application starts, the value is null. Let's look at the code. You expect the console to print the value, instead, it prints null. The first reaction is usually my configuration is wrong, so you check your property file, everything looks correct, the property exists, the spelling is correct, the application starts successfully, so why is the value still null? At first, this feels like a Spring bug, but it is not. Spring is doing exactly what it is designed to do. Let's look at another example. Suppose you have this method in post construct. Now the output becomes the expected value. Same property, same bean, same application, but now it works. Why? What changed? The only difference is timing. The constructor runs first, post construct runs later. So somewhere between these two, Spring injects the value. That raises a much bigger question. When does Spring create your bean? When are dependencies injected? When are at value fields populated? And at what point does Spring create the proxies behind transactional, async and cacheable? The answer to all of these questions is hidden inside one process, that is Spring Bean lifecycle. Once you understand that lifecycle, all of these Spring mysteries suddenly become very easy to explain. Let's go back to our question. When Spring finds this class, what actually happens? Does Spring simply create an object using new keyword? Not at all. Instead, Spring hands this responsibility to something called the application context. This is how most developers imagine Spring works. Find the annotation, create the object, done. But Spring does much more than that. Think of application context as the central manager of your Spring application. It does not just create beans, it manages their entire lifecycle. Whenever Spring starts, the first major job of the application context is to scan your project. It looks for classes marked with annotations like component, service, repository, controller, configuration. Every class it finds become a bean definition. Notice the wording, not a bean definition. At this stage, Spring has not created the object yet. It has simply discovered that this class should become a Spring Bean. You can think of a bean definition as a blueprint, just like the blueprint of a house. The blueprint tells you which class to create, what dependencies it needs, what scope it belongs to, how it should be initialized. But a blueprint is not the house itself. Only after reading the blueprint does Spring create the actual bean. And this is where the bean lifecycle begins. The application context now starts preparing the bean step by step, not in one step, but through several phases. Now our mystery from section 1 becomes much easier to understand. When the constructor runs, Spring has only created the object. The bean has not completed its lifecycle yet. That's why @value is still null in constructor. Only after the application context finishes preparing the bean does it become ready for use. And that preparation process is exactly what we call the Spring Bean lifecycle. In the next section, we will walk through each phase and see what Spring is actually doing behind the scenes. Now we know something important. The application context is responsible for creating and managing every Spring Bean. But creating a bean is not a single step, it's a complete journey. Let's follow the life cycle of our report service bean from the moment Spring creates it until the application shuts down. Don't try to memorize every callback. Instead, remember this journey. We will walk through each step one by one. Step 1, bean instantiation. Everything begins here. Spring creates the object just like normal Java. Suppose we have this bean. Spring internally creates the object like this. At this point, only the constructor has executed. Nothing else has happened. No dependency injection, no @value, no @auto-void, no proxy. That's exactly why we saw this in section 1, the constructor returning the null value. The bean exists, but it's not ready. Step 2, dependency injection. Now Spring starts injecting everything that bean needs. For example, another Spring Bean or configuration values. Spring now injects both of them. Now the bean finally has everything it needs. This is why at value is no longer null. But notice something, Spring still has not given this bean to the rest of the application. There are still few important steps remaining. Step 3, initialization. Now Spring gives us one opportunity to prepare the bean before it is used. This phase is commonly used to load configuration files, initialize caches, open resources, validate configuration. Spring provides 3 different ways to execute initialization logic. The option 1, using post construct. Unlike the constructor, all dependencies have already been injected. Option 2, InitializingBean. Spring also provides a lifecycle interface. You can implement InitializeBean. Spring automatically calls after property set method after dependency injection. Option number 3, initMethod. You can also configure a custom initialization method. Again, Spring execute this during the initialization phase. The important thing to remember is this: all 3 initialization mechanisms execute after dependency injection. That's why they all have access to injected beans and configuration values. Step 4, BeanPostProcessor. Now Spring asks one important question: does this bean need any additional behavior? This is where the BeanPostProcessor comes into the picture. It gets a chance to inspect every bean before Spring finishes creating it. Suppose we have this bean, payment service, which is having transactional. The BeanPostProcessor notices that this method is having transactional annotation. Instead of returning the original bean, it tells Spring to create a proxy. The BeanPostProcessor does not execute your business logic. Its job is to prepare the bean before Spring makes it available. Proxy creation. This is the missing piece from our previous videos. When the BeanPostProcessor decides a proxy is required, Spring creates a proxy around your bean. This is exactly where proxies for transactional, async, cacheable, and Spring AOP are created. So when we said in previous videos, the Spring proxy intercepts the method call, this is the exact point where that proxy was created. Step 6, bean ready. After all these steps completed, Spring stores the fully prepared bean inside the application context. Now other beans can inject it, controllers can use it, services can call it. The bean is finally ready for your application. Step 7, bean destruction. The lifecycle does not end when the bean is created. When the application shuts down, Spring performs cleanup. For example, you can use pre-destroy or custom destroy method. These methods are called before Spring removes the bean from memory. So the final lifecycle summary is, this is the complete journey of every Spring Bean. And once you understand this lifecycle, the behavior of transactional, async, cacheable and your Spring AOP becomes much easier to understand because they are all built on top of this same lifecycle. Now our bean has completed its life cycle. It is fully initialized. It is ready to be used. But one important question still remains: how many instances of this bean does Spring create? The answer depends on the bean scope. By default, every Spring Bean is a singleton. That means Spring creates only one instance of the bean. Every controller, every service, and every component shares that one same object. For example, look at this code. No matter how many times Spring injects this bean, it always returns the same instance. Now suppose we change the scope. We have mentioned the scope as prototype, let's say. With prototype scope, Spring creates a new object every time the bean is requested. For most Spring applications, singleton is the right choice. Prototype is useful only when every request truly needs its own independent object. There is another interesting behavior. By default, Spring creates all singleton beans during application startup. even if no one uses them. Imagine this service. As soon as the application starts, Spring creates this bean. That means your application startup becomes slower, even if nobody uses this service. Sometimes that's not what we want. Instead, we want Spring to create the bean only when it's actually needed. That's exactly what lazy does. Without lazy annotation, the bean is created during startup. With lazy annotation, Spring waits until the bean is actually requested. This can significantly improve startup time, especially for beans that perform expensive initialization. But remember, there is a trade-off. The first request will be slower because Spring has to create the bean before using it. Now we have answered two important questions: how Spring creates a bean through the bean lifecycle, how Spring manages bean instances using scopes and lazy initialization. Let's finish with a few golden rules that will help you avoid common mistakes when working with Spring Beans in production. Now we have seen the complete journey of a Spring Bean. We know how the application context discovers, creates, injects dependencies, initializes, creates a proxy when required, and finally destroys it. Let's finish with a few simple rules. The rule number 1, constructor is too early for field injection. If you are using field injection like this, don't expect the value to be available inside the constructor. The constructor runs during bean instantiation. Field injection happens after that. So if your initialization logic depends on injected fields, run it after dependency injection. For example, you can use post construct. By this point, the value is available. Rule number 2, don't use post construct for heavy work. Post construct runs while Spring is still preparing the application. So if you do this heavy operation inside post construct, your application startup has to wait, the bean is not ready, and in many cases, the application itself is not fully ready. Use post construct for small initialization tasks. For expensive work, choose a better strategy. Singleton means shared state. By default, Spring Beans are singleton. That means the same object may be used by many requests at the same time. So avoid storing request specific mutable data inside singleton beans. For example, if you take report service having current user is the mutable field. Request A can change current user. At the same time, request B can change the same field. Now both requests sharing the same state. A singleton Spring Bean should usually be stateless. The rule number 4, use lazy annotation for the right reason. Lazy can improve startup time, but it does not remove the initialization cost. It only moves that cost. Without lazy annotation, your application startup will be slow. With lazy annotation, your application startup will be fast, but slow for the first request. So don't add lazy everywhere just to make startup numbers look better. Use it when a bean is expensive to create and may not be needed immediately.